This is yet another variant of a question on principle of moments, and you are not given any numbers per se, but you are supposed to solve this using an unknown x. So the question is that you have this setup and is balanced, and when you bring this setup to a moon with a different gravitational field strength, how will the distance x change when the whole setup is balanced? So the answer to this question is actually very simple. B. That's whether you do this experiment on Earth, on the moon, or anywhere else with a different gravitational field strength, it doesn't affect the perpendicular distance at all. Now, the reason for this is as such. We must first understand that mass of an object doesn't depend on the gravitational field strength. It depends only on the amount of matter in the object. So the mass of these two objects will remain the same, whether is it on the moon or on Earth or on Jupiter and so on and so forth. Okay. Now, next, in sum, the value of gravitational field strength, which is 10 Newton per kilogram on Earth, this G value, it will actually appear in both sides of your principle of moments equation. And mathematically, when you solve for the equation, because it appears on both sides, you will sort of cancel it off by dividing it throughout the equation. Hence, when you use POM, you realize that gravitational field strength doesn't affect the whole equation. It doesn't affect rotational equilibrium. Okay, I will give an example. As you can see here that when we use POM equation, the anti-clockwise moments equals to the clockwise moments. I tried to put in words to explain the equations. So on the left, you have mg. Mg is the weight of an object. All right, so weight of the object is the force that creates the anti-clockwise moment. So I put in mass times g, and of course a perpendicular distance on the left. Now on the right, we have this 100-gram mass, so I put it as a 0.100 kilogram. Again, mg. Mg converts the mass to become a weight, and the weight is the force that creates the clockwise moments. So as you can see, the value of g, which is the gravitational field strength, mathematically, you just cancel it off by dividing by g across the whole left side and right side of the equation. Hence, when we use POM equation, the equation is not dependent. It doesn't depend on gravitational field strength. Hence, in this question, x remains as x.